Imagine this. You live somewhere it rains. A lot. And that rain is messing with your clean energy plans, specifically solar. That place is Tupelo, Mississippi. They get absolutely drenched. But what if that rain wasn't actually the problem? What if it could be part of the solution? Today on the deep dive, we're digging into how Tupelo might just flip the script, turning raindrops into actual electricity.
It's a really cool idea, isn't it? Our mission today is basically to see how a city like Tupelo, with its subtropical climate, I mean, we're talking 53, maybe 59 inches of rain a year, how it could pioneer this hybrid approach. We'll look at the specific chances they have, the tech making it possible, and obviously the real-world bumps in the road.
Okay, so rain and solar panels. Not exactly best friends. How bad is this problem in Tupelo? And what are they doing right now?
Well, picture this: 1,200 to 1,300 millimeters of rain. That's about 47 to 51 inches, spread across maybe 110 days a year. And it's not just drizzle. They get proper downpours.
Yeah.
So all that humidity, the clouds, it really hammers the solar radiance, the sunlight getting through. Even their big project, the 74.5 megawatt Tupelo solar project, its output can just plummet. Like 30 to 50% drops during storms.
Wow, 30 to 50%. That's huge.
It really is. But, and this is interesting, despite that, Tupelo is actually moving on solar. Around 15% of homes have solar already. People are worried about the grid. Costs are coming down. Plus, things like the federal solar tax credit help. But it makes the need for something else during rainy times really obvious. It's a challenge lots of places face, actually.
Right, so the need is there. But rain power, seriously, sounds a bit futuristic. How does that even work? Is it real?
Oh, it's definitely real. And this is where the cool science comes in. The main thing is called triboelectric nanogenerators. TIGGs for short. Think of them as super tiny surfaces. When a raindrop hits, the impact creates a little bit of electricity. It's through something called electrostatic induction, kind of like rubbing a balloon on your jumper, but, on a microscale with raindrops. And the best part, they can make these tins transparent, so you can layer them right onto solar panels. Generate power, don't block the sun.
Okay, hold on. Transparent layers, so you get solar and rain power from the same panel, no downside.
Pretty much. Soochow University actually built a hybrid panel like this. Got 13% solar efficiency while making power from simulated rain, about 0.35 watts per square meter from the rain part, using a graphene tin layer. The idea is maybe offsetting 5 or 10% of that rainy day energy loss.
That's clever. Are there other ways to do this, other rain power techs?
Yeah, a few others are bubbling up. There are piezoelectric panels. You can embed those in roofing tiles. They generate power from the vibration of the raindrops hitting. It's not much, maybe 1 to 2 milliwatts per square meter, but it's something. And then there's graphene-coated solar panels. These work differently. They use the ions, the salts and stuff naturally in rainwater. The graphene interacts with them, separates charges, kind of like a tiny instant battery. In the lab, they've hit like 6.53% efficiency just from that effect.
Okay, so if we think bigger picture, where could you actually use these hybrid systems beyond just like putting them on houses?
Right, lots of potential. Think about agriculture around Tupelo. Agrivoltaics, solar panels raised up over crops. Adding rain harvesting there could be great. Plus, the panels reduce water evaporation from the soil, maybe by 30%. Or in cities, imagine solar canopies over parking lots, or even canals, like they're trying in California. These could catch rainwater for energy and massively cut down stormwater runoff, maybe by billions of gallons. So yeah, it's not about replacing solar. It's about making it more reliable, more resilient, turning that rainy weakness into a strength.
Those applications sound really promising, but you mentioned maybe a 5–10% offset, and some of those power outputs sound tiny. Is this genuinely scalable, or is it always going to be kind of niche?
That's the million-dollar question, really. And yeah, the energy yield is a major challenge right now. For example, a square meter Teng panel in Tupelo. It might generate like 0.138 kilowatt hours a year. That's worth maybe just over 1 cent. So not much.
Oof.
Exactly. And the cost of materials. Graphene, still super expensive, maybe $100 to $200 a gram. Plus, Tupelo's climate. You got humidity, maybe saltwater exposure near the coast, hurricanes. So you need tougher, corrosion-resistant panels, stronger mounting systems. That adds costs, maybe 20% more. These are serious hurdles.
So putting it all together, the amazing potential versus these very real costs and limitations, what's the outlook for Tupelo's hybrid energy future?
I think the outlook is cautiously optimistic, but realistic. Rain energy on its own, no, it won't replace solar or wind, but hybrid systems, they can definitely make the grid more stable, more sustainable, especially during bad weather. They're complements, not replacements. We're seeing cool developments too, like self-cleaning panels using special coatings that repel water, perfect for rainy places, and modular systems like mini grids combining solar and rain power, especially for areas prone to flooding. But moving forward really depends on policy support, state grants for R&D, for instance, and community buy-in, things like local solar co-ops exploring these techs.
It really does show that sometimes the biggest steps forward come from looking at what you have, even if it seems like a disadvantage, like Tupelo's rain, and finding a new way to use it. Makes you wonder, doesn't it? If Tupelo can think about turning rain into an asset, what other challenges or, overlooked resources in our own backyards could be opportunities for a more sustainable future? It's a fascinating thought, embracing everything our environment throws at us to innovate.